Okay, welcome to section 3.8, day 2. We'll take a look at the other three trig functions, inverse trig functions, at this time, the reciprocal trig functions. Okay, we should be able to keep this video pretty brief because we really just need to talk about a couple more derivatives. So I suppose you could figure these out on your own. The goal is to figure out the derivative for inverse cosecant of x. Okay, so we kind of learned our lesson. We had mentioned that it might be a good idea to write this as cosecant of y equals x, and then we can take the implicit derivative of that. Okay, so let's go and do that. The derivative is negative cosecant y cotangent y times y prime equals 1, and we end up with y prime equals 1 over negative cosecant y cotangent y. Okay, and then a drawing has been helpful, as we've seen. Some sketch to the effect of cosecant y equaling x, that is, x over 1. Okay, so remember, this is hypotenuse over opposite. So this is x over 1, or our adjacent side is the square root of x squared minus 1. Okay, so let's go ahead and look at our derivative now, and we'll just insert all of our x's here. So for cosecant y, that is going to be hypotenuse over opposite. So actually, we'll just start off with an x here. Actually, just x of that in black. X over 1. That's cosecant of y according to this diagram. It's hypotenuse over opposite. Okay, times cotangent y. This is, remember, tangent is opposite over adjacent. It's adjacent over opposite. So it's adjacent over opposite. So the square root of x squared minus 1. Okay, so the derivative is officially 1 over, or negative 1 over, x, the square root of x squared minus 1. And the chain rule for that would be, okay, so let's write it down. d dx, CSC inverse of x is negative 1 over x square root of x squared minus 1. Worth memorizing there. And the chain rule, d dx CSC negative 1 of u equals negative u prime u square root of u squared minus 1 . And there it is. Okay, let's look at the derivative of secant inverse. Okay, so the derivative of secant inverse of x, we write it as secant of y equals x. You really should be doing this yourself, really. This would give you secant y tangent y prime equals 1. So that y prime is 1 over secant y tangent y. Okay, and then a drawing where secant y represents x over 1. That would actually look like this now. And your third side would be the square root of x squared minus 1. Okay, so inserting that into our function. Secant is hypotenuse over adjacent, and tangent is opposite over adjacent. So we just end up with the derivative of inverse secant is 1 over x square root of x squared plus 1. So these all start to kind of look alike, don't they? Makes you wonder how many of them you need to memorize before the others will be easy to memorize. So since they're all similar, you might want to memorize just what is different about them, you know. You need to memorize them though. Or you could go through this process. Actually, I kind of tend to do that. I don't feel the need to memorize every little thing. I know the process for writing it in inverse form. I know the implicit differentiation. The truth is, I don't memorize very many things like this in real life. But it might be a good idea for you because you're in a situation where you're trying to test under time. And you do have time for this sort of thing if you're managing time well in other parts of the test. But for young minds like yours that memorize things well, devote the time to memorization. Flashcards is a great idea. Okay, and then one last one, and that's the inverse of cotangent. Okay, so we want the derivative of inverse cotangent of x. Okay, so we'll write this as cotangent of y equals x. We take the derivative. The derivative of cotangent is negative CSC squared. Actually a little bit simpler, isn't it? Inside is 1. So you end up with y prime equals negative 1 over CSC squared y. Drawing where cotangent of y is x over 1. Cotangent is adjacent over opposite. So there's your cotangent, y equals x over 1. Here your hypotenuse is this. Going back to our derivative, we're going to symbol it as negative 1 over. Okay, and then cosecant is hypotenuse over opposite. So we end up with negative 1 over 1 plus x squared. And the derivative then of inverse cotangent is negative 1 over 1 plus x squared. If in chain rule situation, it's negative u prime over 1 plus u squared. Okay, now before we wrap up this video, there's one little thing left. We do have a little bit of a concern with our outcomes when it comes to numerical possibilities, okay? So you do have to go back and look at these. Let's go back to our first one here. Okay, when we did the cosecant, you'll notice that x is a hypotenuse, and we want our x to be positive here. See? So we have to ensure that we're taking that measure. Okay, before we wrap up the video, there's one small precaution. You need to go back. If you take a look at your very first, so I've gone back to page 1 here, we're back to the derivative of inverse cosecant. If you were to graph the inverse cosecant on your calculator, and if you don't know how to do that, you can ask me, but it actually is an entirely decreasing function. It's bound to be domain outside of negative 1 and 1 region. In other words, its domain is outside of negative 1 and 1, but includes negative 1 and 1. It's entirely decreasing, so you actually have to go ahead and put in absolute values here. This prevents the answer from ever coming out positive on the original one. And then the chain rule there as well, you've got the u prime, but make sure you put that absolute value in. The same thing actually happens over here. If you look at the graph for inverse secant, you'll see what I mean. It's quite similar. It's just entirely increasing. So it looks something like this. Okay, oops, it's actually right here. This is a really bad drawing, but trust me that the two pieces are increasing only. Okay, and then this stops at -1, and then starts over here at +1 on the x-axis. Okay, so again, this time the absolute values will prevent this entire expression from ever being negative. And there you have it. It doesn't really matter on this one because there is no way to modify the behavior by putting absolute values on. You've got a 1 plus an x squared, which is always positive anyway. So it is what it is.